So last year we heard from Nick DeUlius from CNX Resources. It was really interesting, I thought, very thought-provoking, led to a lot of sharp questions and so on. This year, I'm very pleased to say that, and I've had a chance to get to know our speaker, Mark Pearson, the last couple of days. He's president and CEO of Liberty Resources. He comes from a long history in energy. I had a chance to be with him in a conference organized by Sid Green last week, which concerned the role of minerals, but not only. And I thought that he had just an absolutely wonderful perspective on what we're talking about here, and particularly concerning the production of natural gas, which he knows a hell of a lot about how it used to be, and how we might perceive it, and how it is now, and where it might be going. So without further ado, I'm going to step aside and give you Mark Pearson.
Thank you, everyone, for the warm Western Pennsylvania greeting and welcome. Go Steelers. Yeah, 4-1. I'm originally from the UK, but my American home is a place called Pittsburgh, Pennsylvania, because I started my career with Gulf Oil over 40 years ago. And it is wonderful to be back here and to be spending a couple of days in Western Pennsylvania. In fact, when I met with Andrew a couple of nights ago, I told him, gosh, I got to remember when I was up here, but I went canoeing up on one of the rivers here, and he kind of guided me towards where it might have been, and I was able to find the location. So it is great to be back. My talk that I put together here today is technology and better environmental practices that are driving the oil and gas industry. And so there's two messages that I want to try and get across to you today. One is to talk a little bit about what's the technology behind the shale revolution that's different from the conventional oil and gas revolution, and to give you a little history so that when you walk away from this, you've got a little bit more knowledge than what you had when you came in terms of what's driving this. And then my own company, we're a private operator. We've been operating in the Bakken Shale in North Dakota and Wyoming for the last 15 years. And I just want to show examples of how our company and how our industry, today's oil and gas industry, with all deference to our friends at Oldsmobile, is not your father's oil field. How this industry operates today is very different to how it operated 10 years ago, and particularly 20 or 40 years ago when I first entered the industry. A little bit on my background. I'm a mining engineer by background. Studied in the UK, BS and PhD, but my PhD was in fracking, how to crack rock with different methodologies of fracturing the rock. In fact, we often talk about in the shale industry that we're really mining the resource today. We're not just drilling a hole in and sucking it out. We're actually mining the hydrocarbon that is in the rock. I've over 40 years in the industry. I started with big companies, learned a lot of stuff there with Gulf Oil, with Arco. Spent 7 years living in Alaska doing North Slope development, where I learned a lot of the interdisciplinary measures that go into oil and gas development work. I taught at Colorado School of Mines for a couple of years. I ran a public service company for a time. And then for nearly 20 years now, I decided to go snowboarding. I decided to go running an oil and gas companies, private oil and gas companies in Denver, and snowboarding at the weekends with my kids and my wife. Currently Liberty Resources 2, we just sold our assets. They were at 20,000 barrels a day. We sold those assets, and we're actually in the process of launching Liberty Resources 3, and I'll maybe talk a little bit about that on the panel later this afternoon and what's driving us at looking at natural gas. I also chair an oil field services company, and I'm a tech guy. I've presented or published nearly 60 papers over my career. And different things, had a number of awards from our technical society, the Society of Petroleum Engineering, and kind of I'm at the point in my career where I've kind of gone through a lot of companies, or rather they've gone through me, and And I appreciate, Andrew, the opportunity to come and share some of that with you. Okay, we're going to talk about the shale basins. If you haven't seen this map, the orange is where you see where the shale basins are. And of course here, we're in the Marcellus and the Utica that we're looking at. But I'm going to talk a little bit about the two basins that drove the oil and gas industry and the shale revolution. The first is the Barnett Shale in North Texas, and the second is the Bakken in North Dakota, where I've been operating, and I've had the privilege to be working the last 15 years. Okay, so Fort Worth, it's on the Fort Worth Basin where the Barnett Shale is. It was just the first rock, the first shale rock that was actually commercially exploited in a significant manner. And by shale, it's just very tight rock. Very tight, meaning the hydrocarbon, water, air even, it's very hard to flow. We measure it in something called nanodarcies, which are 10 to the minus 9 of a darcy. That's a flow unit that we use in hydrology and in petroleum engineering. And first production out of this Barnett Shale actually happened way back in time in, it was 1977. And the production there, in 1997, and the production for the next, I can't even read it myself, 76. It was actually at the end of 76. And production for the next 20 plus years, you can see, was just very small, up to 5 million cubic feet a day. Not a lot as operators tried new wells, drilled new wells, tried to stimulate the rock, try to get hydrocarbon to flow. And then in 2002, one of the operators there did an experiment where they had a vertical well and they had an offset well that they put some listening devices way down in it, and they pumped a new type of frac called a slick water frac. And when they did that, they measured the noise being emanated by the cracks as they were generating, and then mapped them out and realized that we were actually creating, with this slick water fracturing, a much more complex fracture network for production. And what happened there is that was a very successful well. The operator drilled 7 vertical wells, fracked them with this slick water production. And here's a production plot, a cumulative frequency plot. Those 7 wells averaged their first 6 months just under 1 million cubic foot a day, 0.84 million cubic feet a day of production. And that was an impressive gain over what had been going on the prior 25 years. And then engineers kind of looked at this map some more and thought, well, what if we actually drilled a horizontal well going northwest here and actually did a whole series of fracs down it? And so they actually tried that in some wells. They ran 21 wells. Some of them were cemented, some of them were not cemented, and more than doubled the production coming out of the wells. In fact, I can remember in 2005 being in my office in Dallas, and kind of the report came over from someone, gosh, did you just hear in the Barnett Shale, company XXX just did 15 frac stages in a well, in a Barnett Shale well, and suddenly things changed. Well, this was the production on a different scale of that first 25 years from 1976 onwards, and this is what happened. Production just grew in 5 years, grew from 2005 to 2010 to 1.8 BCF, billion cubic feet a day of production. Since then, the field has peaked. It's now producing about 800 million cubic feet a day of gas. But a total step change, that was the shale revolution. That was the start of it in the Barnett Shale. Well, here's a plot for the Energy Information Agency. And you can see back in 2008, that orange bar there, that orange wedge, that was the Barnett Shale. Over half of U.S. natural gas production from shales back in 2008. But as we took those lessons to other basins, you see the Haynesville coming on, you see the Permian growing, and of course, what you know here, Pennsylvania, the Marcellus shale growing to the largest natural gas producer in the country today. In fact, it's kind of interesting that 85 BCF a day of gas coming out of shale represents 80% of all of the natural gas being produced in the United States. This is from a resource that didn't even produce 25 years ago or didn't economically produce. 80% of our natural gas, that we're talking about natural gas powering everything here, was from a technology that we didn't have commercially available 20 plus years ago. Well, my own company, I've been working over 15 years in the Bakken in North Dakota. Our company's headquartered in Denver, Colorado. Operate in Wyoming and North Dakota. And if you look at a map, this is what's called a structure map. So the contours are the depth of the rock. And so where it's hottest, it's deepest there. That's about 250 miles across, 350 miles north to south, covering western North Dakota and eastern Montana there. And what I've done there is I've just plotted a little black dot for every well that was drilled in this time period. So from 1953, when first Bakken oil production started in North Dakota, to 1970, there were 50 wells drilled. And you can see they were kind of in a line there. They were on a geographical arch called the Antelope Arch. It was just an anticline that had some natural fracturing associated with it. So when vertical wells drilled in, they would produce. And over the next period of time, from the next 15 years, from 71 to 86, industry was drilling 8 wells a year. And those 8 wells were along structural features, something called the Nesson anticline, that's that northern feature in the middle right, and also on the southwest on another structurally faulted area called the Billings Nose. And then we started horizontal drilling. We found down in that Billings Nose area that we could drill horizontal wells into the natural fractures, and they'd actually produce a little better. And then development shifted to Montana, to a subfacies, a type of rock at the edge of the basin called the Elm Coulee Field. And we had a period of 5 years where development was focused primarily in the Elm Coulee, Montana area, drilling 100 wells per year. And then industry found on the eastern side of the basin a similar thing, better quality rocks. And so the wells were drilled on the east and the west of the basin. And the first few wells were drilled in the middle part. We call that the central basin. But those wells were totally uneconomic. In fact, here's a plot showing some of the first wells are on the bottom here, that in a 6-year period, those wells cumed a total of about 60,000 barrels of oil. Okay, now 60,000 barrels of oil, right? If oil is if oil is $50 a barrel and 60,000 barrels of oil in 6 years, that's $3 million of revenue for a well that cost you $8, $9, $10 million. Plus you've got to pay taxes, plus you've got to pay royalty owners. Totally uneconomic. But what we found is that as we divided up the sections of the well into mechanically isolated different parts, and we call those stages mechanical stages, and do different fracs in each of those stages, suddenly we go from 60,000 barrels in 6 years to 60,000 barrels in 3 to 6 months. And suddenly the economics have totally changed through the application of the technology of how we're fracking the rocks downhole. Well, what happened? The whole basin gets filled in, drilling 1,500 wells per year, 11,000 wells drilled in a 6-year period. Things were pretty crazy in the Bakken during this period. And today, a more gentle, sort of sustained level of just under 900 wells a year being drilled. Production in the Bakken, production went from 100,000 barrels a day in North Dakota, conventional and unconventional here, to 1.5 million barrels a day. And today it's plateauing out at around 1.15 million barrels a day of oil. So that was the first shale oil development that became economic. Again, similar to what happened in the gas markets, the oil markets were the same. The color hasn't quite come out here. On the top, there's a pink area that we've gone from 300,000 barrels a day from tight oil production to 9 million barrels a day. And that top wedge is the Permian Basin that's driving U.S. oil production. 9 million barrels a day from shale oil production out of 13.4 million barrels a day. About 75% of our oil production is coming from these shale oil reservoirs. You see the Bakken is still there, the second largest production, the Eagle Ford in Texas, the Niobrara Codell in Colorado, and then a number of other plays. So again, in 20 years, totally changed the U.S. energy position, not from oil being created, but by the application of technology, changing a resource into a reserve. Okay, well, what's really driven that? What's driven it has been this technology that the media likes to call fracking. A tech guy like me, we call it hydraulic fracturing, but we can call it fracking today. I don't have a problem with that. If you look, fracking was developed in 1947 by a predecessor company of Amoco called the Stana-Linda Oil Company. First wells fractured were in Kansas and then Oklahoma, and then it spread from there. And what I got a plot of here is just the number of wells per year that were fracked and the percentage of the total number of wells. And you can see that in the first 35 years, about 40% of all the wells in the U.S. were being fracked using hydraulic fracturing. Drilling peaked in the U.S. in 1981, December of 1981, with 4,500 drill rigs running, and we were producing about 8.5 million barrels a day of oil. So 4,500 drilling rigs and producing 8.5 million barrels a day. Well, then fracking really took over. So the brown dashed line, over 90% of all wells, 95% of all wells are fractured today in the United States. And you see a little blue wedge right at the bottom? We're just beginning to see horizontal drilling and horizontal applications taking off. A lot of those to fractured carbonate formations that were not fractured. And then the beginning of maybe 35% of wells being fractured. And then look at what's happened in the shale revolution. The percentage of wells that are horizontal wells that are being fractured are just taking off, and with over 90% of our wells now. But our industry is now, blue bars, a horizontal industry. So it's a horizontal industry, whereas 25 years ago it was a vertical industry. It's a fracked industry as opposed to a half and half fracked and unfracked industry. Well, what's that resulted in? It used to be that drilling of wells was the most important thing and the largest capital spend in our industry. Today, the fracking and supplying water is more than double the amount of expenditures compared to drilling. And in fact, the actual drilling of the wells is only the fourth largest component of being an oil and gas developer today. So big change that we're really a fracking industry as opposed to a drilling industry. Now, I'm going to talk a little bit about the environmental sides of that because it's really important. I consider myself an environmentalist. I also happen to be pro-development. So I want to talk about three things here of how industry and companies like mine have reduced our environmental footprint. And we'll talk about surface land use, noise and traffic, and reduced emissions. In the old days, in the 70s and 80s, when I entered this industry, if we had a 2-mile by 1-mile area that we would call it a spacing unit, a drilling spacing unit we were going to develop, we would perhaps develop it with 32 wells like this on 40-acre spacing or 64 wells on 20-acre spacing. In fact, I was flying out of the Midland Airport just a couple of months ago. runway 34, and you look out to the left as I'm taking off, and this is what you see in Midland. And what you see 8 rows of wells per mile here. It's 20-acre spacing, vertical well development. A lot of surface use. Every 660 foot, another pad, another drilling pad impacting the environment. Well, today, we developed that 2 mile by 1 mile spacing unit with 4 wells typically in the industry. And they're spaced 1,300 feet apart, but just 4 individual wells. And if you choose to come to the Centennial State and come to Colorado, and you fly into Denver Airport, this is what you're going to see about 10 miles to the north of Denver. Those pads are 4 miles apart. We've gone from 660-foot spacing to 4 miles apart for these pads for horizontal well drilling. And the drilling itself, I pulled up here. This is a picture I just happen to have in my archives of a development I was working in Wyoming 20 plus years ago. It was standard to have a pit. It's a lined pit. It's monitored by the state. We called it a mud pit or a reserve pit. All of our drilling muds that we were drilling out these wells, everything went into this. It had to be reclaimed. The liners are folded in, but you're burying the waste on location on each pad. That was standard operating practice 20 years ago. Today, no drill cuttings, no reserve mud pits in the industry. We dewater the muds, we recycle it, we dewater it, and the solids that are left are hauled to a permitted location. We have walking rigs. This is a standard rig. This is in one of our operations. These rigs can stand up and just walk from one location to the other. We used to have to move location, have trucks, 50, 60 trucks, moving a rig, taking it down, moving it. A rig will typically stay on location 2 to 3 months or even longer in one location and reduce the amount of traffic. From a safety standpoint, we have automated pipe handling systems so people are not getting their fingers caught and so on, and we don't have the same accidents. And a significant number of our rigs are dual fuel rigs, meaning they can run on natural gas as well as diesel. And there are a number of rigs that are electric rigs as well. So the completions, I'm going to talk about that part of our business. The completions is the connection of the well to the rock. So everyone talks about the oil and gas industry as the drilling of wells. I would actually argue as the completions engineer that is actually connecting the rock to the pipe that's going to connect it to, and transport the oil and gas to the surface. We call that completions engineering. This is an aerial picture of a frac site that I was running 35 years ago in East Texas, the Cotton Valley Formation. And you see that big area, 20-acre pad location. 2/3 of it filled with big tanks that are filled with the water that we're going to frack. On the left-hand side, these yellow transports here, they're sand units. Each of those are containing about 300,000 pounds of sand. And they would take about 4 days round the clock or a week working just daylight just to fill up all of the sand and the fluids and all the traffic that was going to location there. A lot of potential for fluids, a lot of temporary hoses that were hooked up, equipment that would come on location in the afternoon, rig up, spend 1 day fracking, and leave and go to the next location and road to the next location. Well, here's a modern day frac site. Okay, and what do you see the difference? There's only a few tanks there because everything's being pipelined. They're just the working tanks, the holding tanks. Down at the bottom here, we have our chemicals that are coming to location. Typical chemicals that you're going to find in your own kitchen, but they're all contained in chemical transports here with pads around them to make sure that if there is a drip, if there is any leakage, it's not going on the ground. Our sand here is coming in containers that are gravity-fed containers. We're not blowing sand and silica dust into the air for the employees and the public to breathe. The fluids and the sand are mixed together in a couple of blending units. It then goes to the horsepower that is going to provide the energy to crack the rock. We control everything in a control van, and then it goes down the wellheads. And what's interesting in our industry as well is that, this is one of my own locations here, where we're fracking and cracking the rock. But you notice here at the foreground, we've got all the production tanks, all the production facilities already built, because we're also running something that we call green completions. So when the well starts flowing back, we've already got all the production facilities built, and the gas is not being flared, it's being captured straight away and sent to a pipeline. Let's just move on.
Standing right next to the houses that are 500 feet away. And right now we're fracking at 80 barrels a minute. See if you can hear it. Can't hear anything.
So in areas like Denver, where the DJ Basin has come up against development, we can even be fracking and running our wells very close without disturbing neighbors, disturbing the population around us. Okay, quickly, let me just finish up with a little bit on production operations and the kind of things that industry is doing. This is just a shot of one of our company's production facilities. You can see there that everything is surrounded by steel dikes to protect for a spill. On the right-hand side, you can see that we've got hermetically sealed liners underneath all the tanks, so that if there is a spill, that it doesn't go in the land, doesn't cause any pollution whatsoever. On our vapor recoveries from our tanks, all of the vapors are recovered. At one time, industry would typically be flaring that gas, became an issue, so industry started installing something called vapor recovery units. I happen to be on location on the startup of one here. We go from 500,000 cubic feet a day of gas being flared to very little, and once we sort it out after a few days, to nothing being flared on location. One of the sources of methane emissions on oil and gas operations are our separators. These are three-phase separators that separate oil, water, and gas that comes out of the well. The gas comes up at the top part of those units. And then there are level controllers that used to be gas-operated, natural gas-operated. They were causing 65% of the leakage of methane gas on our locations. Many companies now have changed those all out to electric controllers so that we're not leaking the gas. So again, just continuous improvement in operations in how we run our business. Number of other industry improvements as well in operating practices to reduce our impact. So my summary thoughts: today's unconventional oil and gas industry is not your father's industry. Horizontal drilling has allowed the industry to be much more concentrated and spatially separated than earlier industry development. Significantly less land use, less traffic and noise, and that concentration allows the economic justification for better health, safety, and environmental investments and procedures. Operations frequently have reduced emissions with natural gas or electric-powered units. There is zero waste left buried on location. Our central production facilities reduce leaks and emissions per well, and detailed and regular leak surveys are mandated, and the standard operating procedures are mandated by the states in which we operate. And many operators have gone to continuous emissions and leak monitoring as well to report, as Mike was talking about this morning. So the USA is an energy powerhouse, producing more oil and gas than any other country, with some of the cleanest environmental standards in the world, and an industry that is committed to continuous environmental improvement. So with that, I'll say thank you. I'll leave you with a couple of slides here. One is a drilling rig up in the plains in North Dakota, a canola field next door to our operations running away, and also to remind people in places like North Dakota, for 4 or 5 months of the year, this is actually a better picture of what we're working with than the top ones. Thank you.
Thank you, Mark. We are running a little bit over time, but does anybody have any questions for this very, I thought, detailed and thought-provoking presentation? Mark's not going away, so you'll have plenty of time to interact with him as well. Anybody? Okay. Ben?
Many thanks.
Just one quick question. Can you talk about produced water? I keep hearing this is a big challenge in the Permian Basin. Is that a challenge in the Bakken too? And maybe explain what the industry is doing to deal with this challenge and what you need from regulators to help solve it.
Yeah, produced water, when we produce fluids out of the rock, we got water, oil, and gas. In the middle, in the deepest part of the basins, we tend to have more oil than gas. As we move out and becomes thermally less mature, we typically end up with more water than we do oil. So for every barrel of oil in my company's operations, we were producing 3 barrels of water. Most of that is re-injected into deep aquifers. The industry has run into problems in some geographic areas, like in the mid-continent, a little bit in the Permian because of the volumes, if it's high volumes, or if those injection zones are close to basement rocks. And so that was a big change that happened in Oklahoma and the mid-continent. So I think it's being regulated. I think it's being regulated appropriately by the states that are in charge of regulating underground disposal and so on. And it's just part of the business of putting back into deep formations that are already full, already have saline water in them, putting produced water, brine water, back in. It's a continuous process, but I think it's being appropriately regulated. Where there are issues, the state regulators are stepping in and making sure that good industry practices, good operating practices are being maintained. Sid?
Mark, we've seen such drastic changes the last quarter century. What would your speculations on what we might see in the next quarter century? I'll be gone, but a lot of people here will be around yet.
I think it's continuous improvement. We're still working on engineering these fracks, and we even use the term now, mining the hydrocarbon out of the rocks. So the engineering of that is something that industry is still studying, putting instrumentation, fiber optic cables, listening devices and so on downhole so that we can understand that and can engineer it better. So I think you're going to continue to see improvement in that technology. But as I mentioned earlier this morning, there is hundreds of years of resource available. And so we will continue to see that technology development and the application of that technology.
Please join me with a round of applause for Mark.
Thank you.
If I could ask the next panel to come up, and we'll move some chairs off here because I think we're pretty crowded. Our final panels will be a little smaller.